Hello and welcome back. So far we have understood what is k-means clustering algorithm, and then we understood the k-selection processes like elbow curve and silhouette score, and we have clearly understood how silhouette score works also. Okay, in the previous example what we have seen, the iris dataset, the elbow curve gave us intuition on good intuition on how to choose k, the best k, but silhouette score actually failed. Let us try to apply the same k-means algorithm on the what you call it as the ministry dataset, the digit recognizer dataset, handwritten digit recognizer dataset, and try to apply the both approaches, elbow curve and the silhouette score, and see which works good, and then try to take the output of the k-means clustering algorithm and add it as a new column to the dataset and try to build a model and see whether the model's performance improves or not. So we are trying to take the clustering algorithm, unsupervised learning algorithm, to help improve performance on supervised learning algorithm. As we know, the classification problem, in a classification problem, the target variable is kind of cluster only. If there are 10 records belonging to 0, that means that's one cluster, and 20 records belonging to 1, that is another cluster. Like that it is, right? Y variable can be considered as cluster in a classification problem, right? So here also we are not going to take the y variable, keep it aside, do clustering with k-means clustering and find out best k, find out the clusters, add those cluster numbers as a new column. We have 784 pixels in the dataset. We are going to add a new column to the dataset, the clusters as cluster numbers as new column to the dataset, build a model. In this process, we are going to use pipeline and feature union, another important class provided by scikit-learn. So let us jump in and see how we are going to do that whole exercise. So I have taken the dataset, and one more point is that k-means will take a lot of time on a mid-size dataset, right? That's what I am trying to prove here. So mid-size dataset, we have got 42,000 records and it takes lots of time. So it took around 5 to 6 hours for me to execute this and come out with a result. I'll upload this file onto the site. You can download it and you can also try it out. It takes lots of time. So I have taken the digit recognizer dataset, which is nothing but ministry dataset, MNIST. This is a handwritten digit. Somebody took pictures and then flagged it, and it is very useful in understanding machine learning. So I have taken the same dataset and I have chopped off y, the labels, and took only x, and then I am doing k-means clustering for with k from 3 to 60, and with 3 I did k-means clustering, right? When I did fit, the model understood 3 clusters it actually did, and when I predict, right, for each record it is going to give a cluster number. Okay, now inertia, I am actually capturing the inertia WCSS for 3, and again I am calculating silhouette score, right, and saving it into the same process whatever we did in the previous file, right? The same process. That was a small data set and small code. You will understand better. Now you will be able to do it better here. Okay, so we have captured for 3, 4, 5 like that till 60, and I am printing silhouette score here. If you see this, it started at 3 clusters it is actually 0.05, and 6, 7 it is 0.66, at 8 it is 0.73, right? So around 8 clusters is what it is suggesting, but as the data set we know there are 10 clusters, because 10 different kinds of 0 to 9 numbers are there and their pictures they are, right? When the k-means clustering did clustering, right, did this grouping, right, it found only 8 because of the way it is doing the clustering, right? It is actually trying to find out the nearest neighbors, right, and then trying to assign same cluster number and then centroid, and because of that process it found 8. And if you see, right, the silhouette score is raising and going down and raising and going down like this, and I plotted the graphs. If you look at elbow curve, right, here till here it is it is a steep fall, but it is not elbow, right? It is a kind of smooth curve. Sometimes we may get confused. where exactly to take, or which k is the best, we cannot decide when you look at this. Now most probably you can take 10 or 8 here, because the steepness maybe till 15 it is good, right? From that it is kind of flat, right? So but it is smooth, right? You cannot actually make a decision. Elbow is not clearly came as the previous example. If you look at this, right, the elbow is clearly like elbow, right, like that it is, right? But here it is smooth, so you cannot decide. In this case, Chilote score will help you, Chilote plot will help you, or Chilote analysis plot, the knives kind of a plot I showed you, right, that is also going to help you. So if you look at this, it is actually showing that somewhere there is a peak, it is close to 1. The average Chilote score is close to 1, that means the clusters are, the separation distance is good and clusters are formed properly. Okay, so I can take 8 as the best cluster K, the best number of clusters K. So I have taken 8 and then fit predicted. When I fit predict, what happens? For each record, it is going to assign a cluster number. Okay, so like that, for 100 records, these are the clusters. First record belongs to 3, second record belongs to, this is not number, handwritten digit number, it is just a cluster number assigned. Cluster numbers are random, it is not related to the y variable. But what we can do is, we can take these cluster numbers and take y variable and build a model and see how it works. That is one experiment you can do. And sometimes people actually do that also to get good results. What they do is, they take the original data set, take only input variables, do clustering, find the best k, find out the clusters for each record and take that as x and the actual y variable as y, and build a model. That may give you more accuracy than the all x's and y. So you can do that experimentation here. But what I did here is, I kind of visualized it, but what I did here is, I tried to H stack the cluster number to the data set. What is H stacking? I've got 784 pixels columns and around 33,600 in train set. I joined the cluster numbers to the data set. This is the original data set, and I have joined that cluster numbers. For each record there is a cluster, right? I joined that as a new column, 785th column, and then I built a model. Okay, before going there, I tried to do the PCA, the dimensionality reduction of 784 pixels, and took cluster as the y variable and tried to plot it. See this color is cluster, principal component 1 z1 and z2 are the x and y. So if you see this, right, there are overlapping clusters, and the clustered, the distance between clusters is kind of less, kind of a thing is happening here. Okay, so this gives you a high level view of how the clustering happened. When you reduce the dimensionality to 2 and then try to do it as a plot here. Generally people use t-SNE, I am using PCA, but anyway data gets damaged and it is not going to be the ultimate whatever, but gives you a high level view. Okay, just for getting a feel of how the clustering happening, you can do this visualization. So let us jump in and try to use the unsupervised learning's outcome, the cluster numbers, as a new column in the data set, and try to build a model and see whether performance improves or not. On the original data set, I have got 92% accuracy. I think you have seen it in the clustering, the binary class classification and multi-class classification. This is multi-class. 92% F1 score we have got, and I am actually H stacking the cluster numbers to the data set, and now I did feature standard scaling and then built a SGD classifier, right? Clusters 8. No, this is normal model, and no, this is cluster model, and I have got 92% only. Okay, 92% accuracy only. This is 8 clusters I combined. So here we saw that 8 clusters is good, right? So let us try to, this is the same thing I have done with the pipeline. In a pipeline you can pass multiple steps, right? So this is first step and this is second step, but the first step is a feature union. So H stack cluster labels is a feature union. What I am doing here is, I am passing the original data. When I said fit, right, I am passing the digit X train and Y train, and it is going into, in the pipeline, it is going into H stack cluster labels, and in the H stack cluster labels I said feature union. When I say feature union, the same input, the X digits, will go to k-means cluster and standard scaling. If you want to pass the same X to multiple transformers, you should use feature union. Then what happens? This actually does the k-means clustering. Okay, I did not pass the k here. Okay, I passed k here. Okay, so this does the k-means clustering, and this does the feature scaling of the original data, and the next step is SGD classifier. So instead of we manually doing clustering, taking the output of 8 clusters and passing it to the model, 18 clusters and passing it to the model, 37 clusters passing it to the model, 100 clusters and passing it to the model, I have built a pipeline, I have passed parameter grid, and I have created a grid set CV where it actually does those iterations. So it builds 4 models, each with cross validation 10, and I mean that means 40 models it builds, out of which it chooses the best hyperparameter. What is the hyperparameter it is trying to choose? K-means clustering, the n number of clusters, the k it is trying to choose. If you see this here, I have in the pipeline I have H stack cluster labels, a feature union, and which is inside pipeline. So generally if you have one transformer or predictor present in a pipeline, you use the predictor or transformer underscore the hyperparameter name. But here there is a feature union, inside it a predictor, a classification model, and a transformer, right? So you have to pass the feature unions variable name underscore the algorithm name underscore the hyperparameter name, and then we passed, and it actually built 40 models, and it found the n clusters. Where is the n clusters here? K means algorithm auto copy. 8 is the best n clusters it chose, and we have got 90% accuracy. Even with 8 clusters, right, it did not give good accuracy. That means the clustering is not adding much value to the data set. So this is all experimental thing, right? While building models in real time, you have to do all these kinds of experimentations and see where I can get the highest performance. That's what I'm striving to show, or what happens in real time. That's what I'm trying to show you. So you try to play with this code, it will take lots of time. We're going to upload this file into the website. I hope you got the essence here. The point I wanted to explain here is feature union, which is very useful when you are trying to do these kinds of activities. Okay, thank you.